Now we have an ionic radii. So the first thing is that you should know that what is an ion. As you all know that atom is neutral. Like if we talk about any atom is neutral because in it number of protons are always equal to number of electrons, right? So that means there is no charge on the atom. But whenever atom lose or gain electron, then it acquires a charge. And there can be two charges. It can be atom can have a positive charge or can have a negative charge. So only two kinds of possible charges are there which can be on atom when it lose or gain electron, that is a positive and a negative charge. So I think you got it, that atom is otherwise neutral, but whenever it loses or gain electron, it becomes a ion, it acquires a charge, and the atom with the charge is called as ion. Atom with the charge is called as ion. For example, suppose we have any atom and it loses electrons. As we know that this is a feature for metals, right? They only lose electrons. So let us take an example of sodium. Atomic number is 11 and configuration is 1s2, 2s2, 2p6 and 3s1. It will lose one electron, right, in order to acquire a stable electronic configuration. So it will lose one electron, and after losing it will form a positively charged atom which is called as cation, and here its electronic configuration becomes 1s2, 2s2, 2p6. So that means the shell gets fully filled. That means then you can say the shells which are present are completely filled and it becomes stable. So for stability only it loses an electron, right, and after losing it acquire a number of positive charge which is equal to the number of electrons it will lose. For example, here it has lost only one electron, so that is why it is acquiring a one positive charge. But if this sodium will lose two electrons, it will acquire a two positive charge. So in the same way, the number of electrons which it will lose, the same kind of positive charge it will acquire. Likewise, it can gain electron also. For example, we have chlorine. Atomic number is 17 and configuration is 1s2, 2s2, 2p6. 3s2, 3p5, it becomes 17 now. So it needs one electron because after gaining one electron, its shell will be fully filled. That means it will be 1s2, 2s2, 2p6, 3s2, 3p6. All shells will get complete and it will become stable. But when it gains an electron, it acquires a negative charge. That means it forms a anion. I think it's clear that what is ion and why atom lose or gain electrons to achieve stability, and after losing and gaining electrons it becomes an ion which is probably called as cation or anion. Now taking into consideration its ionic radii, so it is assumed that whenever the positive and negative ion approach each other, they touch each other like this due to attraction, right? So here if we want to talk about their ionic radii, it is suppose this is its nucleus and this is its nucleus. So it is equal to the effective distance from the center of nucleus of the ion. Effective distance from the center of nucleus of the ion up to which it exerts its influence on the electron cloud. That means it is a distance from the center of nuclei to a region where you can say its effect can be felt. So that much distance is called as an ionic radii, whether we are talking about cation or whether we are taking into consideration the anion. So how the ionic radii actually varies now? Ionic radii varies in the same way as the atomic radii varies along group and period, right? That means along period the ionic radii also decreases and along group it increases, the same reason which we did in atomic radii. But you need to know this, like if we have a parent atom, we know that whenever it loses electrons, it becomes a cation, right? And whenever it gains electron, it becomes a anion, right? So if we compare the size of cation, which is there is cation and anion with parent atom, we'll see that cation is always smaller than parent atom. Cation is always smaller than parent atom and anion is always bigger than parent atom. Let us find out that what is the reason behind. See, if as I wrote a configuration for sodium, so sodium has three shells. This was nucleus, one shell, second shell and third shell. This is what was there, 1s2, 2s2, 2p6, 3s1, first shell, second shell and third shell, right? And when it loses electron, then its shells are probably 1 and 2. So that means it has lost its shell. Now the shell is only 2 shells it is having. So obviously it is having 2 shells, that means it is losing electron, that means the entire shell is being lost. And when the entire shell is being lost, then but the nuclear charge remains the same, because it is the electrons which are lost or gained, right? So that means the nuclear charge remained the same, and the same nuclear charge is now acting on the lesser number of electrons. So that means obviously it is going to attract the electrons more effectively and the size will decrease. I'll write here. So why the size is smaller? The size is smaller because it loses its entire shell. It loses its entire shell, due to which the same nuclear charge now acts on lesser number of electrons, thereby the size decrease. That is the reason that cation is smaller as compared to the parent atom. Likewise, we have seen that anion is bigger. So we know that anion always gain electron. Like if we take an example of chlorine, here what was there? It had, actually this was nucleus, it has 1, 2nd and 3rd shell. So let's make 1, 2 and 3 shell. In the first shell the 2 electron was there, in the second it was 8, right, and in the third it was 7. Now it gains 1 electron. So that means this 7 electrons now becomes 8 electrons. So that means the same nuclear charge is now going to act on the more number of electrons, right? And moreover, so that means we can say that nuclear charge actually decrease. And moreover, due to addition of electron to a same shell, the inter-electronic repulsions will increase, because the electron is added to a same shell. So obviously the reason is that the repulsions always make the size bigger. That is why anions are bigger than parent atom. So I think you can compare the size of cation and anion with the parent atom. It's very easy and it's very important also. Now we have another thing, that is isoelectronic species. Isoelectronic species are those ions which have same number of electrons. Iso means same, electronic means electrons. So they have same number of electrons, but still they differ in the nuclear charge. As I have few examples for you, it is N3 negative, O2 negative, F negative, Na positive, Mg2 positive and Al3 positive. All of them have 10 electrons. All of them, like every ion in it is having 10 electrons, but still they differ in size. As we know that, so let us arrange them in according to their sizes. As we know that cation is always smaller, so we'll just look for the cation first. These are the cations with positive charge. So that means it has lost 3 electrons, it has lost 2 and it has lost 1. We know that more the number of electrons being lost, so obviously the size is much smaller. So that means out of these 3, aluminium 3 positive is the smallest. After that we have Mg2 positive and then we have Na positive, right. So that means this is the smallest one, and out of cation this is the biggest. Now if we talk about anions, we know that anions are always bigger, more is the charge and more bigger it is. So obviously N3 negative will be quite bigger, then we'll have, we are writing in the descending order now, because this was the smallest, then so we need to write here the smaller one only. So out of them, which will be smaller, this is going to be much bigger. So F negative will be smaller, followed by O2 negative and then N3 negative. So keep in mind that more is the negative charge. More is the negative charge, more bigger it is. And more is the positive charge, much smaller it is. So this is how you are going to arrange by taking into consideration the magnitude of the charge. So I think it's clear. The more is the negative charge, like N3 negative, O2 negative, N3, F negative. 3 negative was quite bigger. So more is the negative charge. It is quite big because we know that anions are always bigger, right? And if we talk about the positive charge, then more is the positive charge. it is much smaller, right? So this is how, by taking into this thing into consideration, you can actually arrange the isoelectronic species depending upon this this factor as we discussed. So this was all about the ionic radii. I think you got it, that what is the atomic radii, what is the covalent, metallic and van der Waals radii, how it varies along group and period, and you also know that what is ion, how it is formed, what is ionic radii, how you can define it, right? And you also know that how it varies along group and period, and you can also compare it with the parent atoms also, and you know about how to arrange the isoelectronic species according to their size, right? So this is all about the ionic radii. So just start practicing at home, see more questions and just try to predict that which is smaller, which is bigger. Just you need to do is that you need to keep these factors in mind, right? So this is all about the atomic radii.